We are studying the molecular basis of the neurological alterations in essentially minimal hepatic encephalopathy, and we will focus today on the mechanisms of some types of cognitive dysfunction. And we believe that most neurological alterations in minimal hepatic encephalopathy are due to alterations in neurotransmission. For our studies on the mechanisms, we are using animal models of minimal hepatic encephalopathy, mainly rats with portacabal shunt. And to assess the role of hyperammonemia, we are using a model of chronic hyperammonemia without liver failure that we get by feeding rats an ammonium-containing diet. And with these models, we study different types of learning and memory, which are moderated by different mechanisms involving different brain areas. These are some of these tests that we perform, testing the Y maze, Morris-Water maze, radial maze, and today we will focus mainly on the Y maze. In this test, the walls of the maze can be white or black. When they are white, food is put on the right. When they are black, on the left. And rats must learn where is the food depending on the color of the wall. We put the rat here, and depending on the color of the wall, she must learn where is the food. They perform the test 10 times per day, and we assume that they have learned when they perform correctly the 10 tests on the same day. We are using these tests for many years, and we have found that the ability to learn this test is modulated by the function of the glutamate nitric oxide cyclic GMP pathway. Activation of NMDA receptors increases calcium in the postsynaptic neuron. Calcium binds to calmodulin and activates nitric oxide synthase, increasing nitric oxide, which activates guanylate cyclase, increasing cyclic GMP. And part of this cyclic GMP is released to the extracellular fluid, and this allows us to measure the function of this pathway in vivo by using microdialysis in freely moving rats. We set a microdialysis proof in the cerebellum of the animal, and we take continuously samples of the extracellular fluid, and we can measure cyclic GMP. We can also add NMDA through the same proof, which activates the pathway and increases cyclic GMP. And the increase in cyclic GMP induced by NMDA is a good measure of the function of this pathway in brain in vivo in freely moving rats. We have studied this system in many different experimental conditions, and we have found that situations which impair the function of the pathway impair the ability to learn this Y maze task.